Hello everyone, my name is Lakshmi Prasanna. Now I'm going to give a brief explanation about washing machine simulation using PicsimLab, which we have simulated as a part of our internship at emertxe Information Technologies. It is a virtual internship. Now I'm going to give a brief explanation about this project presented by me and Saikiran Polishetty. And these are all the contents which we are going to discuss now and which we were taught in the internship. And it is a 6 week program with a strong focus on practical learning. It combined theoretical sessions with coding and real time projects, which we have simulated. It is a combination of C programming and microcontroller so that we can simulate an embedded system. We know that embedded system is a combination of hardware and software. Hardware here is a microcontroller, and the software which we have used is C programming. Basically, it is embedded C, but here in this internship, uh, our experts introduced C programming first as a basic thing. And this project served as a real world application of all concepts taught. We have worked under the guidance of industry experts. The main goal of this internship was to gain an experience with the embedded C and microcontroller based systems. It aimed to bridge the gap between academic knowledge and industry requirements. We have learned how to control hardware using code. We also explored how to integrate peripherals in embedded systems. This experience is useful for learning about embedded job roles, and this internship helped in developing confidence in system level thinking. And coming to about embedded systems, basically embedded system is a combination of hardware and software to perform a specific task or a function given. It includes processors, memory, and input output interfaces, often sometimes sensors and actuators based upon the functionality. Mainly, those are used for advanced uh, applications. These systems are present in many industries like automobiles, medical devices, home applications, mobile phones, industrial machines, etc. Embedded systems operate under real time constraints. The main goal is to perform dedicated functions repeatedly and accurately. Embedded systems are very compact, reliable, energy efficient, and designed for high performance and performing specific tasks. And embedded systems are classified into following types based upon the functionality and performance. Those are standalone, real time, a network, and mobile. Real time again classified into two types, hard and soft, based upon the time constraint. Coming to standalone, these systems work independently without needing a host system like a PC. They contain all required hardware and software within a single device. Example includes washing machines, calculator, digital watches. They perform a specific task repetitively, and the system is self-sufficient and doesn't rely on external networks. It's ideally a simple and task-oriented devices, which we can say. And coming to real-time embedded systems, classified into two types. Uh, these are the systems respond to events within a defined time. Our real-time systems must meet deadlines strictly, or failure may occur. Soft real-time systems allow small delays without system failure. Examples like which we can take a car, airbag system in a car, where time plays a crucial role. And for soft real-time systems, we can consider some mobile applications, video streaming apps, etc. There, the plays a. And coming to network embedded systems, these systems are connected to networks such as Wi-Fi or Bluetooth. They share and receive data from other systems or the internet. Some of the examples include smart home devices, smart TVs, and IoT health monitors. They are real-time communication and control systems. This networking capability enhances functionality and remote access. They are essential in modern connected applications, which we can see all the time in our surroundings. And coming to another embedded system, mobile embedded systems. These are portable and compact, which are designed for specific functions like communication, media tracking. These systems are small, lightweight, and can move from place to place easily. Examples such as smartphones, which we use daily, GPS devices, fitness trackers, and digital cameras. And here are all the embedded systems, types of embedded systems, which we have discussed in this internship. Coming to C programming module, our experts have introduced firstly about C programming. What are all the essentials of C programming, like data types, operators, loops, functions, arrays, pointers. We also discussed about functions, recursions, memory, macros were also discussed. Logical and bitwise operations were also taught, and also some pre-processed directories and strings. Here are all the discussed topics in C programming. Data types, modifiers, qualifiers, loops, jumps, decision making statements, storage classes, and derived functions. Here uh, are the all things which we have discussed. And coming to microcontroller module, as I said, embedded systems is a combination of hardware and software. We have discussed about software which is required for the simulation of the microcontroller, And now microcontroller module. We have learned to interface peripherals using microcontroller here. Practical tasks included like LED blinking, switch detection and timing usage, LCD programming. Interrupts and keypad interfacing were also introduced here, and control of devices like buzzers, fans were also implemented. This module enabled full system interaction using code, that is emertxe. It bridged hardware and software effectively in general purpose. But here in this project, we don't have any hardware. We simulate the hardware using firmware, and the project requirements and design are the goal was to simulate a washing machine using PicsimLab. As there is no hardware here, it is a virtual internship. We have used peripherals like keypads, buzzer, fan, LCD. User input was taken through a LCD keypad. Timers and interrupts processed input in real time. In LCD, we can observe many options. There, we can choose for the functionality. Output was shown on the LCD and activated fan buzzer accordingly. This project applied all learned concepts in the practical design. The tools and development environments, software which we have used for software, like writing code, we have used MPLabX, PicsimLab, X8 compiler, and no hardware was used, but we have simulated the board, that is PIC microcontroller. The languages used in simulation was C and embedded C. And the tool explanation will be given by Mr. Sakiran Polishetty.
These are the tools which we are using in this washing machine simulation. First one is MPLabX IDE. MPLabX IDE is an integrated development environment used to write, debug, and program applications for microchip microcontrollers like PIC, which means it is used for different options like short pressing of key for navigating the options and long pressing of key for selecting the options. It also sets timers and interrupts in the program. The second one is X8 compiler. This is the block diagram. The middle one is the microcontroller, which is PIC16F877A. These are the inputs which are fetched by this microcontroller. Here switch 5 which we are using for powering on the system, and switch 6 for pause or stop, switch 4 for navigation, like for changing the options or selecting the options. Switch 1 is to check the door status, like whether the door is open or closed. And these are the outputs. LCD display is used to show any messages or notifications. Fan is like a washing machine motor. It runs when the motor runs, and fan will be in off state when the motor is in off state. Buzzer is used as an beep alert or for any notifications. PIC microcontroller is programmed for different combination of inputs to give different outputs. This is the pin diagram of a PIC16F877A microcontroller which we are using in our simulation. These are the implementation details. Embedded C used for all logic. Header files created for modular code. Timers used for event timing. LCD for real-time feedback. Buzzer and fan for output actions based on user input. This is how our simulation is shown in PicsimLab. These are the switches RB0, RB1, RB2. RB0 is a switch 1, RB1 is a switch 2, likewise RB4 is switch 5. Here switch 5, this RB4 is used to turn on and off the washing machine. This is the LCD display which shows the messages or a status of the machine. This is a fan which indicates the motor of the washing machine, and this is the buzzer which gives a beep alert sound, and it is also used for any notifications. MPLabX IDE. These are the header files of this program, and these are the source files of this program. This is main.c. It is the source file that contains the actual flow of a washing machine program, like changing one operation mode to another operation mode. It also detects the key pressed and it takes action accordingly. This is the washing machine function definition source file. It contains all the functions which are called from the main.c. In this, the set time is the most important function used to specify the time for each washing program selected by the user. Here, the time will be different for all combination of operations. It is the washing machine header. It contains the function prototypes of all the functions. This is main.h contains all macros used in main.c. This is digital keypad.h contains macros used for key presses. Digital keypad C contains logic to detect short key presses used to navigate the options and also to detect long presses which is used to navigate to next program. This is timers.c used to enable timers and interrupts, and isr.c is used to implement the actual counting logic.
Yeah, this is the washing machine simulation board. This is the there is the microcontroller pic. RB are the switches, 1, 2, 3, 4, 5, 6. And for turning on the machine, we use switch 5, that is RB4. For selecting of and navigation of options, we use the switch 4, and we can observe that on the LCD screen, washing machine program, heavy, delegates, whites, etc. For selecting it, we have to long press switch 4, that is RB3, so that we can select the option. Here I have long pressed switch 4. It is water level. For navigating, we use switch 4. We can observe in the LCD there are options like high, max, auto. Yeah, and for switching on the machine, we use switch 5, and for turning off it we use 6. Here I have turned on by using switch 5, that is RB4. So you can observe that the fan is running, that is the washing machine is running, and that was the simulation of washing machine using PicsimLab. And I conclude that we have gained a strong foundation in embedded C and learn about the hardware. It is very helpful for gaining knowledge in embedded systems. Emertxe has helped us a lot and giving real-time exposure of embedded systems, like designing embedded systems. We have understood the end-to-end development cycle in this project, and hereby I can say that I'm very confident to take up any embedded roles or advanced projects. Thank you, Emerson.